Gaming on PC is fun, but what takes it to the next level is playing it anywhere, on a train, plane, or even in the bathroom. However, there are not many games ported to Android from Windows. But would you believe that there is a way by which you can play PC games on Android or any ARM processor like Snapdragon, Mediatek, or Apple Silicon? And it's possible through emulation and translation layers. But don't confuse both of them as the same, as both are very different things. Emulation recreates an entire hardware environment like the CPU, memory, display processor, and audio processor virtually in the software. It is a digital imposter that tricks the software into thinking it's running on the original physical machine. Or in simple words, old computers had different dedicated components like integrated circuits to run dedicated codes for a game, and they work simultaneously to give you any particular animation or effect in a game. But in modern computers, everything is done under a single CPU, which is often called an SoC, system on chip. That's why both old and modern computers are different from each other. Sometimes old computer had dedicated chips for doing particular things, whereas modern SoCs don't require anything like that. Yeah, modern SoC also has different types of chips, but they all consist in a single processor die. And the code written for an old computer will not be able to run efficiently on a modern SoC. That's why their emulator comes in handy, like RetroPie or RetroArch. So they create a virtual environment so that the game believes it's running natively on its original hardware. Whereas a translation layer is a software which will translate any API of a game into a different API for which it was not made, like running Windows game on Mac, Linux, or Android OS, and vice versa. Every operating system has its distinct APIs. For example, Windows uses different API like DirectX for graphics, Teamworks API for input, and many more. Android uses OpenGL and Vulkan for graphics. You can understand an API or application programming interface as a set of rules that allows different software applications to communicate with each other. And as smartphone processors are advancing day by day, it's not a big issue for ARM SoC to run x86 games. They have come a long way, but the thing which is holding them back is the emulation of hardware and translation of APIs. And the day is not far off when game developers only need to optimize their games for a single platform, and it will automatically be ported to another platform, which is a plus point for every developers as well as gamers. Just like what we are seeing with the Steam Deck, it's happening with Windows game where they are automatically translated for Linux with the help of Wine and Proton. And recently Valve, the parent company of Steam, is taking it to the next level as they have announced 3 more products in their Steam hardware library, which are the Steam Console, Steam Machine, and the most important, the Steam Frame. This is not just a VR headset which can only stream games from another main PC or laptop to the VR. It's a full-fledged device on which you can download or install games. It is powered by a Snapdragon 4nm processor, the Snapdragon 8 Gen 3, with 16GB of LPDDR5X RAM. It's a full-fledged smartphone fitted under a VR headset. Now here, I am not going to talk about its features like pancake lenses or eye tracking features. We will stick to the topic, which is on the platform on which it's going to launch. The Steam Frame is going to run on Steam OS, which has access to all our Steam library, and we can even run games out of Steam library. And this is all possible due to translation and emulation. Emulation will emulate the hardware part of converting x86 processor code language to ARM processor language, which is often called ISA, Instruction Set Architecture, and the translation layer will translate APIs, and this is going to happen with the help of FACS translation layer. This is an open source project funded by Valve for since a decade. That's why in today's video I am going to test this concept on my smartphone, for which I am going to use GameHub and Winlator emulators. And for this experiment I have 3 test subjects: Redmi Note Note 7s, Sony Xperia 1 Mark III and Infinix GT 10 Pro. You can see the specs of these smartphones on the screen and their benchmark performance also. As you can see, all the processors are pretty outdated, but among these, the Redmi Note 7s has a very old processor, so I am not going to make it a time bomb. Other than this, the Snapdragon 888 is a flagship processor launched in the last quarter of 2020 and the Dimensity 8050 launched in May 2023 second quarter. I will also run the games on an x86 processor to get an idea of how our games are performing, for which I have a Ryzen 3 3200G with integrated Vega 8 graphics. So now I have downloaded all the games which I am going to test. These are not so high demanding games which will make my PC cry, but still we can get an idea from this. Before test, I want to say one thing, that I was not able to run games directly from Steam library, even when you can see that GameHub says that it's compatible. As you can see in my Steam library, it says that the Metro 2033 Redux game is compatible with GameHub and my smartphone also meets the system requirements. So for now, I have downloaded games from websites like GOG Games and Indie Gala, which will provide DRM free games. Now, the main testing part, for which I have selected 4 games: GTA San Andreas, IGI 2, Return to Castle Wolfenstein, and at last Street Karate 2. These are not just random games, these are the games which made my childhood. But here I was disappointed to see that my latest phone, which is not more than 2 years old, was not able to run every game at its best. It has problems like frame rate drops and very low frame rates, and even some games are not starting up, they just crash. And I think the problem was not with the SoC, it is related to RAM, as it has only 8 GB of RAM and still in daily use 60% of it's already used by the system. So maybe this amount of RAM is not enough to run games smoothly. On the other hand, my another smartphone can run games pretty smoothly, leaving some extra space in RAM for other tasks also. But the bottleneck is the SoC, but still it performed better than my expectations. At first, my Infinix GT 10 Pro gets 18 to 24 FPS in GTA San Andreas, but it shows very low FPS, whereas Sony Xperia gives a constant 29 FPS of gameplay in GTA San Andreas, and it's very smooth to play. And on my PC, I get constant 25 FPS and absolutely no lag. Then comes Return to Castle Wolfenstein. It crashed on my GT 10 Pro and gives 60 FPS on Sony Xperia.
Ah, there you are. Shackles that one to the wall.
As well, 91 FPS on my PC. It gives very smooth experience to play on PC as well as Xperia. I love it. Then comes Street Karate 3, which gives 60 FPS across all devices, as is expected, as it is not a very resource intensive game. I also tried IGI 2, which crashed on the GT 10 Pro, but it was also not able to run on Sony Xperia. So I tried different emulator, which is Winlator. On that, Xperia was able to run this, but it was giving around 6 to 5 FPS hardly. And this game also crashed on my PC. I don't know why. I think it might be a game issue. So from this test, we got an idea about how these test subjects perform in our experiment, and the performance directly depends on how powerful processor you have, and these processors are going to become more powerful in future. Now, I am not going to test each and every game, as it is a time consuming process. If you want, you can test this on your own device. It's not a complex task. If I can do it, you can also do it. And yeah, you need to deep dive into these emulator settings to make some games run or to optimize any game for better FPS. You will get tons of tutorials on PC emulation on ARM devices on YouTube, and the motive of the video is not to show gameplay or to test my devices. I just want to talk about this revolutionary technology. And see, x86 to ARM emulation is not a new thing, as Apple has its own platform named Rosetta 2 and Windows has Prism, where they also do the same thing to translate or emulate x86 application for ARM platform. But they are not open source or community driven project. They are completely closed project. So that's it. It's a huge topic which I can't cover in a single video. I have an idea to create a complete ARM PC emulator from hardware modification, just like a normal x86 handheld. So stay tuned for that project and I see you in my next video. Till then, goodbye and stay safe.